In this video, we'll give you a quick overview of what we've achieved in this exciting initiative. PowerStorm is part of the 6G SANDBOX project, focusing on enhancing energy efficiency and performance in next-generation networks. Who are we? We are the Laboratory of Internet Computing at the University of Cyprus. Our key objectives for this project: first, we aim to evaluate and enhance the energy efficiency of 5G and 6G enabled deployments, with a particular focus on IoT applications. In addition, we test various scheduling strategies within Apache Storm to assess and optimize the balance between system performance and power consumption. Furthermore, we aim to measure energy usage and system load in these infrastructures. Finally, we want to evaluate distributed applications over edge-centric environments. To achieve these goals, our team deployed a testbed integrating IoT devices, 5G networks, and a distributed data processing application on top of Apache Storm. Regarding monitoring, we've utilized smart plugs and monitoring agents as to collect real-time energy, utilization, and performance metrics. Before we dive into the results, let's first take a look at the setup of our experiments. To comprehensively evaluate energy efficiency and performance, our experiments were carried out in two distinct phases, each focused on analyzing different aspects of 5G-enabled networks. Phase 1, with an emulated infrastructure, and Phase 2, with a real-world deployment. In each phase of our experiments, we compared 3 Apache Storm scheduling strategies. First, the round-robin scheduler, Storm's default strategy, which evenly distributes tasks without accounting for resource constraints. Second, the resource-aware scheduler, which assigns tasks based on available computational resources, aiming for better performance balance. And finally, PowerStorm, our custom-built scheduler optimized for energy efficiency, designed to intelligently balance workload and power consumption. Moving on to Phase 1, we emulated 2 testbeds, both utilizing a variety of edge computing nodes, but each operating under different network conditions. Our key findings revealed that PowerStorm reduced energy consumption by 15% compared to the baseline. Additionally, Resource-Aware Scheduler showed mixed results. Moving on to Phase 2, we transitioned to a real-world deployment. In the first setup, we've used a variety of user equipment typically found in edge environments, all connected via Ethernet. In the second setup, we deployed 3 virtual machines to simulate a different edge infrastructure. And in the third setup, we combined both environments into a hybrid deployment. Both the second and third setups operated over a 5G network. Here are our key results. So let's take a closer look. For this phase, in regards to performance metrics, specifically latency and throughput, our results showed that PowerStorm consistently outperformed all other configurations in every case. The resource-aware scheduler was more effective in terms of overall performance. Ethernet provided slightly better performance than the edge cluster, mainly due to the local placement of the data generator. However, the most significant finding was that 5G-enabled user equipment devices outperformed Ethernet connections, highlighting the superior performance and robust quality of service delivered by 5G radio access networks. Although both PowerStorm and resource-aware schedulers delivered superior performance, they consumed more energy than the default round-robin. The energy increase is expected as they prioritize performance, often selecting more nodes or power-hungry devices, which this reveals the trade-off between energy and speed. In regards to the deployment insights on energy consumption, the edge cluster was the most power-hungry setup due to conventional server hardware. Ethernet and 5G setting had comparable energy usage, but 5G significantly boosted performance. Interestingly enough, the 5G network demonstrated a better balance of performance and energy efficiency compared to traditional setups. Looking ahead, we aim to expand our evaluation to a broader range of streaming workloads on 5G and 6G-enabled infrastructures. Lastly, as ML and AI inference moves closer to user equipment, we will optimize our services to improve performance, focusing on latency and energy efficiency for streaming inference tasks. To wrap up, here are the key takeaways. 5G ran outperformed Ethernet, offering better quality of service and scalability for edge applications. Smart scheduling is vital for balancing performance and sustainability. And finally, PowerStorm delivered the best performance with manageable energy trade-offs. Want to learn more? Head over to our Docs and GitHub page.